Hi, everyone. Thanks for joining us today. I'd like to introduce Lukasz Hubner from Thermo Fisher Scientific. Lukasz, can you tell us a little bit about yourself and your role at the company?
Sure. Hi, everyone. Hi, Trevon. I'm really glad to be here. So, my role at Thermo Fisher is software architect, which describes I play with software a lot. But I would say not only with software, because since we use software to automate our tools, automate our microscopes, I also play a lot, or I'm heavily involved with all the automation that we do for our dual beam systems, especially around template. So I would describe my daily job as working with the automation and development of the automation here at Thermo Fisher.
Let's talk about the Helios 6 HD. It's been out for a few years. Can you tell us some of the advantages of AutoTEM 6 over the other automation toolkits that are out there today?
The first two words that come up to my mind, if you say HD, is heavy duty, and that's what I understand this tool to be all about, doing the heavy work for our customers. And that's exactly what we did when we started that project. We said, okay, let's put those tools under a heavy duty. Let's make them running 24/7, and let's see what happens. And it happened a lot. And basically, we were constantly looking at, okay, how to improve the performance, how to improve robustness, throughput, how to improve a lot of various issues like reduce the maintenance time, and basically make those tools more suitable to do the heavy duty work for our customers uh, better, and I would say way better than the previous generations of Helios tools.
How are we using machine learning, and what are some of the benefits to our customers?
Machine learning, I would say my favorite topic, because it's today it's everyone is like, okay, machine learning will solve everything, and let's just put their AI and everything will be fine. Uh, Yeah, I would say that's at least partially true. But and that's why we are using machine learning with our late endpointing, so light induced termination endpointing. Uh, but I would say, first of all, I would say machine learning. That's from my perspective not an ultimate solution to any problem, because yeah, it's definitely fancy, but inside it's also very complex. So it only suits the most complex challenges that we are facing also in other industries. But if you ask people that ever did lamella tinning, they would definitely all agree that tinning is one of the most complex challenges in our world. And that's why we are using machine learning there to drive the endpointing, to basically measure how the lamella is thick and whether we should approach more with the endpointing, and or whether we should stop because we already reached the target thickness. So yes, we are using machine learning with the line endpointing to recognize how the lamella is thick. Uh, and that significantly improves the tinning reliability, I would say.
Can you tell us about how Weld Plus stacks up versus conventional thinning techniques for our customers?
Yeah, sure. So if we want to dive a little bit deeper into how the lathe works, and how the weld plus works and what is the benefit of that, uh, I would say the biggest reason compared to the previous generations of of the lamella tinning is that this approach does not rely on a fit performance only. So it does not rely on the consistency of the ion beam shape, but it adapts to, let's say, various ion beam conditions using a so-called closed loop, where during the thinning, it's looking at the cut base of the lamella, and it's evaluating the SEM cut base, looking at the lid lines there. And from that, it's building kind of a feedback loop, how the thinning and the milling is progressing. And if it's progressing faster than we would expect just on the ion beam conditions, it can, let's say, adapt to that, and it can finish the thinning sooner. So the result is exactly what the customer wanted to achieve or a user wanted to achieve, uh, without so much sensitivity of the ion beam repeatability or ion beam shape.
We've talked a lot about the Helios 6 HD. Can you summarize some of the newer benefits for our customers?
HD, I would definitely call it a heavy duty tool, not just a regular microscope, because it's way more robust and way more performant than any microscope we previously built. Uh, in addition to that, it's also pushing the limits of lamella tinning to more thinner lamella, more reliable lamella than ever, thanks to using machine learning and LIT. And I see those things as the major news or major differentiator so of the Helios HD compared to what we've seen before.
Thanks, Lukash, for taking the time with us today to help everyone learn more about the Helios 6 HD and AutoTEM 6.
Thank you, Trevon. It was a pleasure for me, and hopefully see you soon. Thank you.
If you want to learn even more, please reach out to us and schedule a demo of the Helios 6 HD with AutoTEM 6 at one of our nanoports worldwide. Thank you.